tomorrow will be better. A 2 kg mass tied to a 12 cm rope is in circular motion. The tension in the rope is found to be 50 newtons. At what velocity is the mass moving? Follow me, dear friends. Solution. Let's understand that we are in the context of circular motion. And here, the main idea hovers on centripetal force. And what is it? Centripetal force is that force which is necessary to keep an object in that circular path. And it's a contextual force, which means it's a force which depends on the context. In some cases, this same centripetal force is equal to the friction. In some other cases, like in this case, we will examine and we will notice that it is actually the tension in the rope. A stone or whatever mass is tied at the end of a rope, and then the rope is being swung maybe, I don't know, over the head. Now, the force which prevents that stone from going off that circular path is a tension in the string. So the one and sufficient hint in this question is to understand that the centripetal force Fc is simply provided by the tension in the rope. But by definition, we will say that Fc by definition is given by the mass, the square of the velocity divided by the radius. So this is what we want to equate to the tension. From here, we will just make V the subject of the formula. So from here, I'll start by cross multiplying. I'll have that V mv square will be equal to R times T. At this point, I just have to divide both sides by m to free up V square. So I'll end up with V square is equal to RT all over m. And finally, to get rid of the square, I'm going to take the square root of both sides. Therefore, V is going to be equal to the square root of radius times tension divided by mass. Be careful here, dear friends. The radius has been given in cm, so you have to convert it to meters. So, therefore, if we do it all well, we will have the square root of, if you convert this to meters, we should have 0.12 times the tension which was given, and then all of this divided by the mass, which is 2. And if you do this well, we should have a final answer of 1.7 meters per second. Tomorrow will be better.